Hey, hi, hello guys, welcome back to Code with Nani YouTube channel. Today we're going to discuss about placement problem series based on the loops concept. So when you concentrate on the core companies or dream companies, they'll ask you these type of basic problems based on the loops. So today we're going to discuss about pattern problems, reversing number, palindrome, Armstrong number, factorial, Fibonacci series, and prime numbers. So guys, pattern questions. We did 4 pattern questions. So now let's get into the reversing digit. So what is reversing digit? Reversing digit is like reversing the number. Like let's take an example. N is equal to 1 2 3 1. So reversing the digit will be reverse digit is equal to reversing of this number from the back 1 3 2 1. So how do we gonna do? How do we approach this type of problem? So let's take the value same 1 2 3 1. So we are no splitting out the last digit and adding to this reverse digit. Now in the next iteration we are lefting out 3 and are appending it 2 here 1 1. Now what's the question is, look, how do we cut that last digit? How do we cut that last digit? Again, think of an operator. So what operator will come to your mind? So when you have these type, when you want to cut this last digit, let's think of an operator, modulo operator. Suppose it is an n modulo 10. So when we divided by this with 10, 1 2 3 1, when divided by 10, 1 2 3, so then the answer would be 1230 and the remainder will be 1. So when you take modulus operator between for that n value, what we are going to get, we're going to get the last digit. So with the help of this we will get the last digit as n modulo 2, right? And we will make a separate reversing digit is equal to 0, and we will make reverse digit is equal to reverse digit into 10 plus last digit. Why reverse digit into 10? Because we separated 1. So as a reverse digit is 0, 0 into 10 plus, what is the last digit? The last digit is 1. So what will be the value of RD? RD value will be 1, right? So in the next iteration, 1 2 3 1 1 2 3 1. So right now LD reverse digit value will be 1. So in the next iteration LD is equal to, so also one more thing, so after you done everything, so after you got this last digit, we have to get rid of this one in that n variable. So how do we gonna do that? So let's just divide it with by 10. N is equal to n by 10. So what will happen then? We are dividing 1 2 3 1 with the 10. So what the value will be storing? 1230. Remainder 1. This 123 will be storing in the value of 1. So we only need this 123 because we already iterated and stored as a last digit. So now we have to go through with this 123. So I'll write the code what we are doing. While n greater than 0, until this value of n is greater than 0, where like reversing digit will be 0. What we are doing? Int last digit is equal to n modulo 10, because we are getting the last digit of the number using modulo operator, and we are making rd is equal to rd into 10 plus n is equal to n by 10. Why? Because we need to get rid of the statement which we iterated. In the next iteration we will extract last digits as 3. So in the next iteration we have to get rid of this 3. That's why we are dividing with 10. Get into it. So now let's dry run this problem. So you'll get to know everything about this. 1 2 3 1. So at first n is greater than 0, then ld is equal to n modulo 10, then here ld becomes 1 because we extracted 1 from it, and then rd is equal to, as previously rd value is 0, so 0 into 10 is 0 plus ld, so rd becomes 1, and now n is equal to, from 1 to 3 1 we are dividing with by 10. So as integer only stores the integer number, it will delete the floating point, so it will only store 123. In the next iteration it will check for the 123. As 123 is greater than 0, ld becomes 123, last digit of this 123 is ld equal to 3. So now rd is equal to rd into 10 plus 3. What is the previous value of the rd? Previous value of the rd is 1. 1 into 10 plus 3, so 13. On n value it will decrease to 12, as it will eradicate the floating points value. Now these 12 will go again into this, as n is greater than 0. For that 12, the ld value is, for that particular 12, the ld value is, now ld value is 2, and this particular rd value is 13 into 10, 130 plus 2. So why we are multiplying with 10? Did you observe the pattern? Because 1 2 3 1. So first we separated 1 and we appended here. So whenever we extracted 3, that 1 has to move to the before place, because now the number will becomes 13. So the number is shifted from 1's place to now 10th place. Whenever we extracted 2, the number shifted from 13 to 132. So from 10s to it shifted to 100's place. Whenever I extracted the last number, we appended it here. Then it becomes from 132 to 1321, which means it is multiplying 10 each iteration. That is why we are making rd into 10. So whenever the new number comes, last digit comes, we are multiplying with 10 and we are adding. Suppose 1 2 3, right? So we got 3. Then whenever 2 comes, we are multiplying 30 into 10 and we are adding, so number becomes 32. So whenever the last digit came, we are multiplying with 10, 320, and the last digit is 1, 321. See, the number is reversed. So let's code it, guys. Let's just erase everything. So let's take int rd equal to 0, make reverse digits at 0, while that particular number is greater than 0. What we are doing, making int rd int last digit as n modulo 10, because we are extracting that particular number. And what we are doing in the reverse digit is reverse digit into 10, because whenever each number comes, the original rd value have to shift to the next place, from 10s to 1s to 10s, 10s to 100s. Then we are adding that last digit. Then if you forget to, suppose if you forget to reduce the n value to n by 10, it will keep on looping. Let's take 1 2 3 1. If you forget to delete this number, it still extract the 1 and it will add to the reverse number. It will become infinite loop. So we have to reduce after each iteration. We have to delete these values, then only the number becomes 0. Otherwise the number won't be 0 and it will continue to loop, so it becomes infinite loop. So now we'll make n is equal to n by 10. N is equal to n by 10. So we are printing the RD. Let's run this. See, we give an input as 1 2 3 4 and we are getting 4 3 2 1. Let's take another example. 1 2 3 1 1 2 3 1. It will give you 1 3 2 1. So that's how reversing digits works. And let's get into this. Let's get into palindrome. Many of the dream companies will ask the question from this concept palindrome, which is very important in terms of strings or in terms of a number. So what is a palindrome? So palindrome number is a number when you reverse the number, still it is equal to n. Let's take an example. 1 2 1 2 1 2 1, right? So yeah, reverse this number, 1 2 1 2 1. So still even you reverse this number, the number is same. So these type of numbers are called palindromes. So how do we solve these problems? Use the same concept like we did in the reversing digit. So what we do is we'll check whether the input number and the reverse number is same. If both are same, then it is a palindrome number. So we use the same concept. So throughout the DSA, what we will do is we'll take some of the patterns. So the patterns will be repeating. So there will be some specific default 4-5 patterns for 4-5 patterns and 4-5 methods. So these methods will keep on repeating. So if you learn this reversing digit, and the palindrome will be a easy one for you, the same pattern. So what we do is we'll compare if r is equal to n, then what we say, see out is a palindrome. Is a palindrome. Else, see out not a palindrome. So we are storing the value of n in n. We are making a different variable ans as n. Why? Because we are doing this. Because when you see this program, if you don't store the value of n, the original value will becomes 0. N is 0. Then only we will get out of this loop. So for what value we are comparing? Because when we given 1 2 3 1, and if reverse number is 1 3 2 1, at the end we have to check for both values. If n is equal to r, then only it is palindrome. But after the coming out of the loop, the n value becomes n equal to 0. So by which value we are comparing? That's why at the starting stage we are taking the variable ans and we are storing that value in the answer. At the end we will check for this answer with that reversing digit. So whenever these are equal, then it is a palindrome. So that's what we are doing. We'll check that with ans. Let's run this. Sorry, RD. Let's take an example. 1 2 1 2 1. It is a palindrome. If you check for 1 2 3, if reverse it, it becomes 3 2 1. It is not a palindrome. So that's how the palindrome, reversing number, and So we're done with pattern questions, reversing number, and palindrome. So in the next video, we'll discuss about Armstrong number, factorial, Fibonacci, and prime numbers. So that's it for today video, guys. If you like the video, do share with your friends, subscribe to my channel, and hit that bell icon if you don't want to miss any further updates. So tomorrow I'll come back with a great content, and don't miss out, because tomorrow session is full of a Firefox round, because Armstrong number, factorial number, Fibonacci series, these are the repeated questions that will be asked in the interviewers, like dream companies. So when you target 10 to 12 lakhs, so these are the questions that will frequently asking. So don't miss out tomorrow's video. That's it for today, guys. Thank you. Bye bye. See you tomorrow.